Welcome back. This is video 2 for lesson 4.5. Okay, we're actually going to be solving quadratic equations now. You can use square roots to solve quadratic equations without a linear term, without an x term. For example, if s is greater than 0, then the equation x squared equals s has two real number solutions, x equals square root of s and x equals negative square root of s. These solutions are often written as x equals plus or minus square root of s. So we're going to solve 3x squared plus 5 equals 41. Notice that there's no x term. Okay, we're going to write the original equation, so we write it down, and then we try to isolate the x squared. The first step toward doing that is by subtracting 5. So we'll get 3x squared equals 36, and then let's see, we need to divide both sides by 3 to isolate the x squared completely. So we get x squared equals 12. So at this point, we take the square root of both sides, and remember on the number side, you want to put the plus or minus. And so we get x equals plus or minus square root of 12. Then we simplify. Okay, to do that, we're going to do the product property because 12 has a perfect square factor of 4. So x equals plus or minus square root of 4 times square root of 3. Square root of 4 is 2. And so we get x equals plus or minus 2 square root of 3. And so there's two solutions, 2 square root of 3 and negative 2 square root of 3. Now we can check by substituting them into the original equation. So the original equation is 3x squared plus 5 equals 41. So if we substitute in 2 square root of 3, we're going to have 3 times 2 square root of 3 squared plus 5, and we want to know if that equals 41. 2 squared is 4, square root of 3 squared is 3, 4 times 3 is 12. So we have 3 times 12 plus 5, and we want to know if that equals 41. That gives us 36 plus 5, which is 41, and so it works out. We go over to the other side, and we do the same thing with negative 2 square root of 3. Well, negative 2 times negative 2 is still 4. Square root of 3 squared is still 3, so 4 times 3 is still 12. So 3 times 12 plus 5 is still going to be 36 plus 5, and so we get 41 equals 41. All right, let's look at a multiple choice problem. What are the solutions of the equation 1/5 z plus 3 quantity squared equals 7? Okay, so we want to get to the z. Okay, that's our whole goal. So let's write down the original equation. 1/5 times z plus 3 squared equals 7. So that z is on the inside of parentheses that has a square, okay? But outside of that, we've got the 1/5. So the first thing we're going to do is get rid of that 1/5. And the way we're going to do that is by multiplying by its reciprocal on both sides. So we're going to multiply by 5. So 5 times 1/5 is just 1, so we don't even need to write that down. We've got 7 plus 3 squared equals, and the 7 times 5 is 35. So now we want to get to that z. What we need to do at this point, though, is get rid of that square outside those parentheses. So I'm going to take the square root of both sides. On this side with just a number, this side with 35, I'm going to remember to do plus or minus. Okay, so when I take the square root of z plus 3 quantity squared, the square and square root cancel. So I'm left with z plus 3. And then on the right-hand side, where just the plain number is, I remember to do the plus or minus, and then I have square root of 35. So now to isolate the z, I just need to subtract the 3 over. So I'm going to get z equals negative 3 plus or minus square root of 35. Now, I like to see if I can simplify square root of 35. 35 just has factors of 5 and 7. Neither one of those are squares, so we're done. So the solutions are negative 3 plus square root of 35, negative 3 minus square root of 35, and so your answer is choice C, because choice C is negative 3 minus square root of 35, negative 3 plus square root of 35. Okay, it's always good to see how people actually can use the techniques we use in real life. So one thing that we can do is model dropped objects, and when we're working with that model, we can actually use the technique that we did today. When an object is dropped, if it's a model, it's going to work too. Its height, h, and feet above the ground after t seconds can be modeled by the function h equals negative 16t squared plus h naught. H naught is h with a little 0 at the bottom, where h with a little 0 at the bottom, h naught is the original height. It's the height at time 0, the height when the object was dropped. For a science competition, students must design a container that prevents an egg from breaking when dropped from a height of 50 feet. How long does the container take to hit the ground? Okay, so we're going to write the function. In general, it's h equals negative 16t squared plus h naught, the original height. So we're going to substitute 0 for h because at time 0, when the object is released, it's going to be 50 feet above the ground. So we're going to substitute in 50 for h naught. So 0 equals negative 16t squared plus 50. So we can subtract 50 from both sides and get negative 50 equals negative 16t squared. Divide by negative 16. So we get 50 over 16 equals t squared. We can take the square root of both sides, and on this side that's just numbers, remembering to do plus or minus. So we get plus or minus square root of 50 over 16 equals t squared. And if you use a calculator, you get approximately 1.8. Okay, we could put it in simplest radical form, but we went ahead, used a calculator, because that gives us a little bit more of an idea of how much time we're talking about than just some fraction with radicals in it. So plus or minus 1.8 seconds. Well, we need to reject the negative solution because time must be positive. We can't go back in time. So the container will fall for about 1.8 seconds before it hits the ground. Okay, guys. Again, the book that I use is Larson Algebra 2 by Hope McDougall. There's a picture of the book and some sources for the PowerPoints. Thank you so much for your attention. Guys, in my class, go ahead and make sure you try those problems to try on your own, and we will go over them in class next time before you get started on your rounds. Thank you. Have a good day.